Okay, let's press play. So good morning, everyone. Today I'm going to talk about JupyterLab, one of the newest initiatives in the Project Jupyter ecosystem. You'll see that the subtitle of this talk is Building Blocks for Scientific Computing, or Interactive Computing, excuse me, which I'll describe in more detail during the talk. JupyterLab was developed by a team of engineers from Cal Poly, Bloomberg, Continuum Analytics, UC Berkeley, and Lawrence Berkeley National Lab. And you can see their names here on the slide. It's a great team of developers. JupyterLab is the evolution of the IPython notebook that many of you may be familiar with, and that was deployed around 2011. We've also had contributions from a number of Jupyter team members. I'll show you them in a second. We're very excited about JupyterLab and the features it provides to our user community. Before I go much further, I'd like to thank and recognize the entirety of the Jupyter team for their great work and high level of collaboration across all of our various projects. I'd also like to thank Brian Granger and Jason Grout. Brian Granger will be giving some demos later in this talk, and Jason Grout, one of the core developers on JupyterLab, for the use of their slides and their trust to share this information with you today. So where is Project Jupyter today? Well, the adoption of Jupyter Notebooks has been amazing. Today, best estimates of the number of Jupyter users is somewhere in the millions. I've heard between a little over 1 million to 3 million. It's hard for us to get really hard numbers on that. And the team conducted a user survey in 2015 with a great deal of help from IBM. And here are some results from that survey. Here you see a distribution of the different types of people or roles or occupations that are using the Jupyter Notebook. You can see that data science is at the top there with 25% of the users that were surveyed, and then education and science are strongly represented. I'll talk more about the survey later, but if you want to look at the results in detail and play with the data yourself, there's a link to a notebook file at the bottom of this slide. Write it down really quickly. It's just github.com/Jupyter-design. And you should be able to find it in there. So another metric that the team is super excited about is that there are over 500,000 notebooks in GitHub right now. GitHub has started to index content in notebooks, and we can track these notebooks in the GitHub trending pages. As of last weekend, when I was working on this talk, trending notebooks included a Pandas Exercises repo, a TensorFlow repo, and then at the top there, and then Brian Granger's and Jake Vanderplas's repo on their new visualization library, Altair, is just a few steps down on the list. So really exciting stuff going on there. This is one way of tracking interesting content that is being created in the Jupyter Notebooks. So the Jupyter Notebooks are also enabling reproducible science, a dear interest of the Jupyter team. The LIGO collaboration, which recently discovered the first experimental signatures of gravitational waves, has been publishing all of their analysis through Jupyter Notebooks. You can go to this website here, the LIGO Open Science Center, and download the data. This is available to anyone. There's even a live binder service for this, so people can run these notebooks without ever installing anything. So we're also enabling open data journalism. BuzzFeed sets a great example by publishing its notebooks of analysis in addition to its articles. BuzzFeed may not traditionally be known as a serious data journalism outfit. However, top 10 lists, etc. However, they do have some really good stuff in there, and they have an absolutely spectacular data journalism team. Here's a consumer-focused data journalism article about fixing tennis matches that they wrote recently in January of this year. And anytime they publish an article like this, they post the data on GitHub and all the analysis in Jupyter Notebooks. So through your use, I'm assuming that some of you do use IPython notebooks or Jupyter Notebooks. You may have noticed that the notebook itself, is really more than just a notebook. The latest version of Jupyter, version 4, has a file browser. I'm starting in the upper left-hand corner here. There's a text editor. You can open source code files, .py files, for example, and edit those. There's a full-blown terminal, so you can run VI from the web browser, and of course, you can use the notebooks. So all these different parts of Jupyter, file browsers, notebooks, text editors, widgets, output in the terminal, they're really building blocks for interactive computing. And that is how we think of the Jupyter ecosystem. So what are we hearing from users? As I mentioned a few moments ago, the team conducted a user experience survey in 2015 with a great deal of support from IBM, especially Peter Parente. And this survey showed us who is using the notebooks, how they're using it, and where the needs are in terms of future development. Much of what you're seeing on this slide comes from the survey, but it also comes from watching how people like yourselves are using the Jupyter Notebooks. One thing that came out of the survey is that most respondents who use the notebook use it daily, and after that, weekly. So users are generally spending a lot of time in the Jupyter Notebook environment. In the survey, we heard very strongly from our users that they love the notebook workflow and user experience. However, because they're in there daily and weekly, we've heard that there are also a lot of workflows where the notebook is a little bit painful. So as users start to transition from interactive exploratory work to more software engineering, there are numerous pain points. We've heard things like there's a strong need for more integration with version control systems, more support for better text editors and code editors. With the different building blocks that we have right now, you basically can only get one of those building blocks on one web page at a time. So if you've used the notebook and you've tried to create this environment for yourself, you can't really put a text editor next to a terminal next to the notebook because you just don't have the real estate to do that. And if you take the focus off one, you're not able to see the other things you want to work with. So it would also be really nice if you could take a notebook cell and just drag and drop it over a text file and have that content dropped in the text file. And then folks were looking for types of tools that show up in software engineering workflows like debuggers, profilers, and variable inspectors. So with that, I'm excited to show you our JupyterLab alpha preview. So this is a preview of our alpha version of the product, okay? Like alpha. So please know this is a very early version of JupyterLab, not even a release yet. So we like to think of JupyterLab as a natural evolution of the Jupyter Notebook user interface. Since the team first shared JupyterLab at SciPy, people have been asking us, is this an IDE? It looks like an IDE. And our answer is yes, if by IDE you mean an interactive development environment. So JupyterLab has a flexible user interface that allows it to combine the different building blocks of scientific computing in ways to support the workflows that the user has at the moment, whether it's more interactive exploratory workflow or something that just looks like DevOps or software engineering. So we have a modernized JavaScript architecture underneath this, and it's built using Phosphor.js, which is an open source library for building web applications that have a lot of capabilities of desktop applications. So we're really taking thanks to Brian, we're really taking a design-driven development approach. We have a number of designers working with us on this project, and we're taking user testing very seriously. A number of people participated in user testing at SciPy in Austin recently, and we really appreciate that. The response to JupyterLab has been fantastic over the last month or so. All right. So, as I mentioned, JupyterLab is a very early developer preview. You can download the code, you can play with it, but please don't do any super important career work in it because it could break at any minute. So it's not suitable for general use. The features will change. So at this point, I'm going to move to the live demo. This is my first live demo of JupyterLab, so just bear with me. Good? Okay. All right. And I go totally analog. My notes. All right. So I'm going to go over the interface here as maybe a data science would do it or researcher, and then Brian's going to step in and go over some of the developer features that we've added to JupyterLab. There's a lot of really cool things under the hood that I'd love for him to describe, since he's been so pivotal in moving this forward. So this is what you see when you open JupyterLab. There are two main areas, this area right here, and then on this side. Plus, you also have a right-hand sidebar here that shows you things that you have running. Okay, so on the left side, we have a file browser, and the file browser provides typical functionality that you would see in a file browser, including dragging and dropping of files. So, does this thing work? Okay, great. So you can kind of, not working as well as it was 5 minutes ago. But anyway, just trust me on this one. Dragging and dropping of files. You can control or right-click to open up a shortcut menu to do additional actions on your files. So you can rename files, and it'll give you the typical renaming box. You can also, let me bring that up again. You can also duplicate, cut, copy, paste, etc. So you can also browse directories. I had a breadcrumb trail up here like 5 minutes ago, and it went away. So anyway, usually this will show you your directory structure, so you can go up and down the directory. So one thing to note in JupyterLab is it includes, currently it just includes some basic features of the notebook. As the team works toward creating parity between the classic notebooks and JupyterLab, you'll start seeing updates through our GitHub branches. So over in the main area here, you'll see when you open up JupyterLab, there's a great tour that you can walk through. So you can click on this, take a tour, and it'll go over some of the things that I'll be talking about today. So this is really nicely designed and very descriptive of how the tool works. So this area right here is called the dock panel. This is an area for you to arrange your windows that may include your notebook, your text editors, and the various components you use to produce your analysis. So for example, let's open up, this is the talk outline. Okay, and I can take that talk outline and I can put it over here in the sidebar. That's for later. Put it over here on the sidebar and move it over, so the focus is really more on the main area. So you can really kind of arrange the space however you want as a user. You can put your windows anywhere, which is really useful when you're, especially data scientist, and you have your workflow that you always do when you're pulling in files and doing your analysis. You want everything just the way that you like it. So there are also a number of components that are provided in JupyterLab. So I talked about the notebooks. So we have the LIGO event notebook here that I pulled in, and it works just like the classic notebook that everybody is used to and that everybody loves. Okay, so you can also invoke a terminal from this window. You can open your text editor, and then you can arrange them in the way that you like them. Let's see, we also have the Qt console that is now a browser-based console. Sorry, I'm using Python 2 Purist, so you can just kind of put that wherever you want it. I'm going to hide that. Okay. Let's see. We have consoles. On the left side, we have a command palette. So if you are looking for a command, you can just pull it up here on the left-hand side. It has fuzzy searching. So if you want to find a tool within here, you can just start typing what you're looking for. And here's that Panda reference. That pops up on the right-hand pane, right-hand side. We also have a help menu up here, and the help menu provides an About JupyterLab. Oops, I think I opened too many. And here's our help tab here, and I can collapse that. So under the help menu, you can go to About JupyterLab, and that'll give you that tutorial, the walkthrough that I showed you earlier. We can close that and that. And you can also, if you're working in IPython or NumPy or Pandas, you can pull up those references within the window. So this is an extremely useful environment for just getting work done, right? You never have to put it down to go look something up. It's all kind of in this workspace. Okay. One other thing, so my background is in biology and geography, so I just wanted to show something really cool before I hand it over to Brian. One thing that you can do as a user is you can pull in these GeoJSON files, and you can either, I'm going to first, you can either open the file in the editor, so it's not word wrapping today, so you only see that, but GeoJSON files are a little bit hard to read, but what we all usually want to see is the map. So here, we're able to bring up the data in a map and visualize it instantaneously. So it's super great. So that's a short user tour of what JupyterLab is. If you installed it and looked at it, you'd be able to start working with it. But that's just the beginning of the capabilities of the platform. So just as we're starting to see now the Jupyter Notebook, as popular as it is, it's just the tip of the iceberg for the platform of protocols and messaging system, the specs that the Jupyter project is defining. So at this stage, I'm going to hand it over to Brian, and he'll talk a little bit more about those details.
Hi, everyone. Thanks, Jamie. So I wanted to spend a few minutes talking about JupyterLab from a developer perspective. And in this context, what I mean by developer is not someone using JupyterLab for development or for data science, but more of third-party developers who would like to take the JupyterLab architecture and extend it and add new features. One of the things that we've been really pleased about with the classic Jupyter Notebook is that a lot of people have built custom extensions. There's a couple different ways you can extend the classic notebook. One notion is the idea of a server extension. So you can add new REST endpoints and URLs to the server side of the notebook. The other is the idea of a notebook extension, where you can write custom JavaScript that gets loaded on the notebook page or one of the other pages that customizes the front end itself. And part of the pain that we've experienced ourselves and heard from users is that the development experience on the JavaScript side in the classic notebook is quite painful. Now, part of that is that we wrote the classic notebook back in 2011, and just to give you a sense of where web development was at the time, everyone was using jQuery, and that summer we evaluated Bootstrap and decided, you know what, this is way too early. It had just come out, and we said, we're not going to use Bootstrap. And so this is sort of pre the big revolution in web development that's happened with Node and NPM and React, like nothing like that. And so to say our JavaScript code in the classic notebook is a bit crusty, I think is very true. With JupyterLab, a lot of what we've done is modernize the development architecture. Everything is built using sort of the modern tool chains for JavaScript development. Everything is packaged as NPM modules, bundled using Webpack. The big thing, though, that really took us a lot of work to get right is that we have a web application that is not a fixed set of features, right? Third parties want to extend this application with their own functionality, but they also want to take advantage of the functionality that we have built in. So, for example, a third-party developer might say, you know what, I have this new thing that I want to offer in JupyterLab, and I need bits and pieces of notebooks, maybe an output area, right? I want to be able to display output. And I'd like to be able to call into kernels and manage kernels, but I don't want full-blown notebooks. And so they need bits and pieces of the existing code base. And an important aspect of this is that there's two parts of this. There's sort of the code level statements where you're saying, I need to import the code that knows about how to create output areas or work with kernels. But then in a system like this, it's not just enough to sort of import the code. You also oftentimes need access to runtime dependencies. For example, if you want to work with files in the file system, you need to load the code that knows how to do that, but you also need a live instance of the file browser object that is pointed at the right URLs and is hooked up. And to basically manage these two aspects of sort of loading code on the page that's required, but also loading runtime dependencies of instantiated objects, we've built a plugin system for JupyterLab. And to illustrate what this plugin system looks like, this is the main index.js of JupyterLab. And basically all it is a list of plugins. And these plugins each declare the ways that they extend JupyterLab, but they also declare the other plugins that they rely on. And so basically anyone now who wants to extend JupyterLab can write a plugin, have access to the APIs of the other plugins, and then all you have to do is add a single line to this index.js to enable that plugin to be loaded at runtime. Now, eventually we're going to have nicer ways of sort of adding new plugins than editing the index.js that are user interface based rather than sort of mucking around with JavaScript files. And that's an area we're actively working on. To give you a sense of sort of, well, what types of plugins could you write for JupyterLab? The example that Jamie showed here of the biodiversity, one abstraction that we have in JupyterLab is the notion of handlers that know how to deal with data from particular file formats. Right? So GeoJSON is a file format, and there's a specific plugin for handling and actually rendering GeoJSON files using Leaflet.js. And that plugin is not something we initially shipped with JupyterLab. Someone at SciPy who had never worked with JupyterLab before and was unfamiliar with it wrote that plugin in a few hours so JupyterLab could open and deal with GeoJSON files. Another example is CSV files. So for example, here's a CSV file. If I just double click on it, I see a text, a table oriented view of that CSV file. That again is another plugin, right? It says, that plugin more or less says, I want to be the default renderer for files that have the .csv file, or the .csv file extension. However, if we right-click on that file, and actually I'd like to pause here and just emphasize something. So I right-clicked here and noticed that it entered the rename file dialog. And what I want to emphasize is this when we say this is a preview of the alpha and you really shouldn't use it for daily work, we really mean it. And to give you a sense of that, we ourselves use the Jupyter Notebook for teaching, for doing data science, for doing scientific research. We're users as well as developers. We ourselves are not yet using JupyterLab in our daily work. We're expecting sort of on the 1 to 3 month time frame, we're going to start to transition ourselves. So that hopefully gives you a sense of, yes, if you want to download it and play with it, that's great, but I wouldn't plan on actually using it for daily work. So let me see if I can get this. There we go. So notice when you right-click, you get the context menu. You see open with. I can also open this as just in the standard text editor. And let's get these two files side by side. So here we see we have two views of the same file. And for example, I can go in here to this version of it. And as I edit the text editor version, the table view synchronizes. This is something that's basically provided to someone for free. There's a common model that both of these views use, and anytime either of the views change the model, the other view automatically gets the update. And so getting sort of live editable tables here was something that was very simple to implement. And these are the types of things that you can do with the plugin architecture. Other things we have, and again, I'll just emphasize the level to which we have bugs. So here's a markdown file. Someone at SciPy also implemented a markdown renderer. And you can see here the markdown does not look like nicely rendered markdowns. Somewhere along the way we broke into CSS. But the point is, as you type here, is fun, the markdown preview automatically gets updated. Again, another example of the sort of the extensibility of this architecture. Phosphor 4.js, phosphor.js. How am I doing on time? No, 15 minutes. Okay, that, I was gonna say, we've not talked that fast. So a couple different pieces of enabling technology. The first is that we are writing JupyterLab in TypeScript. TypeScript is a version of JavaScript that has optional typing. And what we found along the way is that building large-scale applications that have sort of massive API surfaces, where you have different components, different plugins, wanting to call into each other's APIs, having typing really makes a huge difference. And a lot of the common bugs that you have with typos and renames and what's the argument type of this particular function, what's the return type, it really helps a lot. And we found that TypeScript is very productive and is enabling us to work, to sustain a lot of people working on the code base at the same time. Whereas in the sort of the classic Jupyter Notebook, the code base sort of could only really sustain maybe 2 or 3 developers at the same time. It was too hard to break, too easy to break things. Another piece of enabling technology is Phosphor.js. Phosphor.js, the way I would describe it is we think of writing an application like JupyterLab in the browser that really is like a desktop app. What do you mean, quote, like a desktop app? Things like the tabbed and paneled layout system here, file browsers, very complex layouts, menu systems, things like the following submenus are a great example that are really hard to get right in a browser. For example, normally in most browser-driven submenus, if you open a submenu and then cross across this boundary where I'm leaving the parent menu, the submenu would stop being open and you'd have to go back up and you'd change it. I mean, I'm sure you've done this a million times. And so there's just a lot of complex logic required to get the submenu to remain open long enough for you to go across that boundary. There's many, many aspects of sort of building web apps that have sort of desktop level capabilities in terms of layout. Another big area is keyboard shortcuts. Getting modern web apps to support international keyboards is a nightmare. And as we surveyed the landscape, we discovered that no one's really solved that. And I wouldn't say we've solved that, but we've at least laid a foundation that we later can go back and really think carefully about international keyboards. So shortcuts, keyboards, we have a very rich notion of a command system. So basically different plugins can expose commands that can be exposed in the user interface through mouse clicks, keyboard shortcuts, menus, and then other applications can also call into those commands. The command system is very similar to the systems that other modern text editors have, such as Atom and Sublime Text and Visual Studio Code. And so basically, think of all those foundational layers that are required to write an app like this that someone might want to use outside the context of JupyterLab, and that's what Phosphor.js is, right? We get a lot of questions along the lines of, well, why didn't you use React.js? React.js doesn't really solve those problems. A lot of the lessons from React.js about sort of data flow and virtual DOM rendering we are using. And so we're still able to take advantage of technologies like that. Phosphor.js really solves a different set of problems than tools like React solves. So what am I missing? Should I think that's good. I think I'll give it back to Jamie, and she's going to fit. So the question is, could I say something about phosphide? So phosphide is a submodule in Phosphor.js that basically takes care of the sort of scaffolding and pulling together of a bunch of independent plugins into an application, and in particular into an application that has a slightly biased overall page layout. So what I mean by that is something that has a top-level menu bar, the right and left sidebars, and then a central dock panel area. Phosphor provides sort of the overall skeleton to build an app like that based on these plugins. But it's one of the many submodules in Phosphor.js. All right, so I think at this point, I'll give it back to Jamie, and she'll finish up the talk.
Great. Thank you so much, Brian. It's fantastic. All right, so let me just transition out of this. So what do you guys think? It's cool? All right, great. Thanks. Super. You may be interested in checking this out yourselves by downloading JupyterLab and providing us with feedback. Remember, this is an open source project, so we're really interested in what you guys have to say and experiences that you have in this environment. So to do that, you can go to github.com/Jupyter/JupyterLab for the code. Please take our disclaimer very seriously. I think we've repeated ourselves many times today about that, yeah, we don't want to break any of your analyses. So getting started, so we have a README file in the JupyterLab repo, and it gives you these instructions, but I figured I would just go over them here just to kind of help bring you along. JupyterLab requires the Jupyter Notebook version 4.2 or later. So to check your notebook version, you can just type in those commands. Then you may need to update your environment. It doesn't take too long, and you can kind of Google it to figure out how to do it for your particular computing environment. So then from the command line, you can either do a pip install or conda install, and then once that's all set up, you just type in Jupyter space lab, and that'll bring up the browser. Okay. So how to contribute? We highly encourage contributions. For JupyterLab, we have regular progress meetings on Fridays at 9 a.m. Pacific. So if you can get up that early on Fridays, please join us. We also post those meetings on YouTube. So if you want to get up a little bit later and just watch the recording, you can do that. I wish I could do that. You can also follow the JupyterLab repo on GitHub to see what work is going on, or you can submit issues. We'll be submitting a couple issues after our demo today. And then I want to give a shout out to our documentation. We've been putting a lot of energy into documenting a lot of the newer features on the Jupyter project. So you can go to jupyter.readthedocs.io. And there's a section on contributing. We even have a nice workflow diagram or flow chart on where to start and what to do at the different decision points. So where are we going with this? What's the plan for the future? As I said, JupyterLab is available as an early preview only. We're not suggesting that you download JupyterLab to start using it in your daily work. Really, it's not at that point. But, and the visual design, the UI, the UX, the interactions, the code, they're all changing very rapidly. If you want to download it and start to play with it to give us feedback, we would really appreciate it. We're in phase 1 right now, and there will be a series of releases of alpha and beta quality that will provide the new UI alongside the classic notebook. JupyterLab 1.0 will be released when JupyterLab basically has feature parity with the classic notebook, so users won't lose any of their workflow features. Then beyond that, JupyterLab will eventually become the default user interface for Jupyter, and the classic notebook will be available and shipped. And then eventually in phase 4, and maybe Brian, you can correct me if I'm wrong, we'll stop shipping the classic notebook. Is that right?
Yeah.
Yep, by default, but it will always be available for use. So one thing that's nice about this is that the notebook server is basically unchanged in this environment. So you can run either front end with the same notebook server. Okay, so with that, I'd like to give special thanks to the JupyterLab team, which is comprised of folks at Bloomberg, Continuum Analytics, and the Jupyter team at large. This is more than a two-year collaboration with Bloomberg and Continuum, and I'd like to recognize Jason Grout, Chris Colbert, Steve Sylvester, Afshin Darian, and Dave Wilmer, who were not here. Brian's here, but these guys wrote most of the code in JupyterLab, and we really appreciate their hard work and dedication. I'd also like to thank the Moore and Sloan Foundations and the Helmsley Trust for funding the work. And thanks to everyone here for your interest in JupyterLab and for your future contributions to the platform. So thank you very much.